Hey, if you're not there yet, everybody needs to turn to page 151 in their workbook. So go ahead and turn to page 151 in your workbook. Make sure you got a pencil or a pen, something to take down some notes, because we're going to be talking about some stuff that could get confusing today, okay? We are in topic 5, block 4 today. And our objectives and our goals today are that we're going to represent integer operations with concrete models and connect the actions with models to standardized algorithms. We're going to be able to understand subtraction of integers as adding the additive inverse. We'll be able to add and subtract integers using a number line, and we'll be able to apply adding and subtracting integers in real-world situations. Right before that, we're going to be able to generate equivalent expressions using the properties of operations. So remember, the properties of operations, y'all use those in the 6th grade, and basically, so probably even 4th and 5th grade. But what that means is you're going to work in order so that you are able to get the answer correct, okay? So looking at what we have today, we're going to start off with some opening questions. And so I want you to think back to yesterday's lesson where we were working on the number line for addition of integers. And so I want you to think about that. And whenever we were adding, like say we did 6 plus 4, how would Archibald move on that number line? What happened?
He would move to the right 6 times.
Correct. And then since we added 4 from 6, he would move where?
When he moves to the right again 4 times?
Correct. And so we would end at 10. So that's how Archibald was moving on that number line. Now today, we're going to be talking about subtraction on the number line. So how could we model subtraction of a positive integer on the number line? What would happen? Like say, for instance, we had, well, like this one that we're looking at right now, 6 minus 4. What's going to happen?
I'm not really sure, but when you go
Move to the left.
Yeah, so say we were at 6, we would move how many units to the left?
4.
4. And then so where would we end up?
2.
At 2. All right. So do you think that integer subtraction is going to be similar or different compared to when we use the algae tiles? Like for using subtraction with algebra tiles, do you think that number line will be similar? Yeah, it'll be similar. It's gonna model us working subtraction problems, and we'll still be able to find our difference, right?
Yeah.
Yeah, it'll just be a little bit different than what we did before, except we'll still be able to model it. So based off of that, what I want us to do is I want us to look at page 8. Now, when I say look at page 8, I'm talking about looking at page 8 on Agile Mind on the computer screen. So I'm going to make it a little bit bigger real quick. All right, so looking at it, what I want us to do is I want us to focus on what's being said here and us try to answer the questions on our workbook on page 151. We're going to be modeling the first 3 questions on our workbook, so everybody should be able to do that right now in their workbook. So if you would, Vincent, I want you to read about Archibald and his new girl, Annabelle.
Archibald suspects that addition and subtraction of integers are related. He asks his friend Annabelle to help him. Annabelle starts by modeling some subtraction problems on the number line.
All right, here we go. So let's look at it. So it says Annabelle's going to start where? Where would Annabelle start?
0.
No, she's going to start at 0. And then it says she's going to demonstrate subtracting 2 positive integers. So that's 6 minus 4. A while ago, Kalia kind of told us what was going to happen. So let's see if it works out the way that she said. All right, so checking this out. What took place?
We went over 6 times to the right, and then we went back over to the left 4 times, and we got 2. We landed at 2.
All right. So would you go ahead and read that down at the bottom for us in the bright yellow, please, ma'am?
So I was writing on the mic thing is it's above the yellow thing.
Okay, I'm going to scroll down just a little bit. Can you see it now or no? Right here where it talks about Annabelle?
Now I can.
Okay.
Annabelle.
We can't hear you.
Every time I unmute, it covers it up.
It's all good. Let's see if Levi can do it. Levi, can you read it?
Read what? I was working on the problem.
Right here.
Annabelle now subtracts by skating backward. Because she wants to take away 4, since she is subtracting a positive number, she's still facing the right. Remember that subtraction and addition are inverse operations because one reverses the effect of the other. 6 minus 4 equals 2.
All right. So let's see what happens on our next problem. So if you have not done this in your workbook right now, what you need to do is you need to draw you an arrow. This is actually called a vector arrow. You notice that this arrow goes from 0 all the way to 6. And from 6, we're moving back 4 units to the left. And then what you can do on your paper is you can circle your answer, which was 2. And so where it says 6 minus 4 up here, you can just write an equal sign and put the number 2 beside it. So if you have not done that, go ahead and do that really quick. All right, let's go ahead and go to our next problem. All right, if you would, go ahead and read that for us, please, Tamarian. Can you read it for us, Devin?
The top part?
Yeah, right here where it talks about Annabelle.
What if Annabelle wants to subtract 9 from 6?
Okay, so if she wants to subtract 9 from 6, are we taking 9 from 6 or are we taking 6 from 9?
9 from 6.
Yes, we're taking 9 from 6. So really that's like saying what minus what?
6 minus 9.
Correct. So since that's 6 minus 9, we're going to figure out what that answer is. All right, so what do you think that Annabelle's going to do?
When she go to the right 6,
Okay.
and then go to the left 9.
That is correct. All right. Does that look good, Devin?
Yes, sir. And
All
you
right.
would end up with negative 3.
Correct. All right, so once again, if you are not working along with us, we're going to go 6 units to the right from 0, and then from 6, we're going back 9 units, and then we're circling our answer at negative 3. We're going to put negative 3 on, I guess it's part B in number 1. So if you can, would you read that for us, please? Devin, read that in the bottom for us, please.
I can't see it because.
All right. I don't know why everybody can't see it. I'm going to read it for us.
Okay, I got it now.
Okay, good.
As before, Annabelle starts by skating to 6 first. Once again, she skates backward to subtract the opposite to the positive 9. Notice that she is now on the left side of 0. The result is negative. 6 minus 9 equals negative 3.
All right, the result is negative, and so we do 6 minus 9, and it equals negative 3. Great. All right, let's look at our next example. Whoop, she's already skating. Let me start her over. Annabelle's always ready to work. All right, here we go. So looking at this, Would you read this for us, Grayson? What's happening?
Annabelle can also subtract negative numbers. She's going to show you -3 minus -5.
All right. So when we're looking at -3 minus -5, what do you think is going to happen? Go ahead,
She
Levi.
goes to the left, -3, and then goes to the right, -5.
All right. So he said she's going to go to the left 3 times, and then she's going to skate backwards 5 units to the right. And so that gives us the answer, what? Correct.
One.
Correct. All right.
This
So
is a lot off topic, but using the background, my head keeps disappearing.
yeah, it kind of does that sometimes whenever you use
You
that.
gotta move your finger over the camera, and then you disappear.
Oh, I got you. That's odd.
Thanks.
All right. So take a look at this. We are subtracting a negative. Remember that if we subtract a negative, that is the same thing as adding its opposite. So if we add the opposite of -5, what is the opposite of -5? Or what is the additive inverse of -5?
5.
Yeah, it's 5. So you could rewrite this as -3 plus 5 equals 2. And that's actually what I want you to do in your work right now. And,
Isn't the answer to D an integer?
well, we're going to talk about that. All right. So ask what question D states, Levi.
Subtracting a number is the same as adding its.
All right. So what we just said was when we subtract a negative number, it is the same as adding its what?
Additive
Good
inverse.
job. Good job, Kendriana. The additive inverse. So everybody needs to put the additive inverse for part D where it is an underlined answer. So when I say additive inverse, I'll write that out for us just in case we don't know how that's spelled. All right, and remember that the additive inverse is also known as what?
The opposite.
The opposite. Good job. So anytime you see the opposite, we need to think what word?
Additive inverse.
Additive inverse.
Perfect. Good job. All right. So let's go ahead and take a look at number 5. And so that's actually what we're going to see what takes place here with Mr. Archibald. All right. So check out Archibald. It says Archibald can skate to the same place with an addition problem. So he notices that we have -3 minus -5 equals 2. All right. So go ahead, Levi.
The additive inverse, you could do -3 plus 5 equals 2.
Correct. And watch what direction Mr. Archibald's going in. Isn't he going in a positive direction?
Yes.
Yeah, he did. Satari, can you read that down there at the bottom about Archibald?
Archibald has skated to -3. He wants to add an integer to get to Annabelle's location. Archibald has added 5 and has arrived at the same location as Annabelle. -3 minus -5 equals 2, and -3 plus +5 equals 2.
All right. All right. So looking at this, is there anyone that is confused on why this is the same? All right. Grayson said he's got it. Grayson, do you want to kind of explain why it's the same?
I don't know how to explain it, but I understand why it's the same.
All right. Well, can you at least just try to explain it with the arrows, Devin?
Like, so Basically, since negative is going behind 0, when you add, when you subtract a negative, you're taking away the negative, so it's gonna go as a positive. If you get what I'm saying.
Okay. So, and in that case, we saw Annabelle, she skated backwards to get to +2, but Archibald knew, hey, you know what? I don't have to do that because subtracting a negative is the same thing as adding its opposite or its additive inverse. So I can skate in the correct direction of going positive and I don't have to worry about falling down like Annabelle. All right, here we go. So look at what's taking place right there. Watch that again. What's happening?
They're swapping out the -5 with the +5.
That's correct. That's correct. Kalia, read that down there at the bottom if you can.
It says subtracting -5 gave the same answer as adding 5. Remember that -5 and 5 are called additive inverse because their sum is 0. The result is the same in both problems, whether you subtract a number or you add its additive inverse.
All right. Thank you. Grayson, were you wanting to add something?
Never mind.
All right. So if you have not answered all of your questions on page 151, you need to do that right now. Remember, we said that this is the answer to the letter D. So if you have not done that, you need to do that now. We've already answered parts A, B, and C on page 151. So at this time, you need to write down additive inverse for D if you have not, and then we're going to flip over to the next page on page 152. So take a look at what we got. If you would, Hagen, would you read all of this for us, please, sir?
You already explored how distances on a number line are related to addition number sentences. Now take a look at distances and subtraction number sentences. You already know that 4 plus 2 equals 6. Means that 6 is the distance of 2 units from 4. Is there a subtraction problem you can write that shows the same relationship among the numbers?
All right, so we have to subtract and show the same relationship. So that's showing us that 4 plus 2 is 6, right? So if 4 plus 2 is 6, what minus what would equal 2?
Wouldn't it be 4 minus 6?
If we did 4 minus 6, we'd get -2.
6 minus 4.
6 minus 4 would equal 2. What about 6 minus 2? What would that equal?
4.
All right. So there's quite a few ways we can show a relationship between these numbers. So let's see what relationship they show us. Now, something I want you to pay great attention to is that they wanted us to focus on this number, and that there is exactly 2 units between them. All right. That's going to be actually very important for us to remember here shortly. So they said that 6 minus 4 equals 2. All right. And 6 and 4 are a distance of 2 units apart on the number line. And it says, what is another subtraction sentence related to 4 plus 2? Well, if 4 plus 2 is 6, we just said that we could also say 6 minus something equals 2. And what did we say it was?
What, you said 4 minus 6?
Right here. It said, what is another subtraction sentence related to 4 plus 2 equals 6? We've already done 6 minus 4 equals 2. So could we say 6 minus?
6 minus 2 equals 4?
Perfect. So they would be how many units away? 6 and 2 would be how many units away?
4.
Yeah, it'd be 4 units away. Anybody confused yet? Everybody feeling pretty confident? If you are, give me a thumbs up. Pretty simple. All right. All right, let's look at number 3. Let's get Malik to read this for us, please, sir.
How consider
Now consider.
Now consider 6 minus 9 equals negative 3. How are the values in the number related to the distance on the number?
All right, thank you. All right, so looking at this, we got 6 minus 9 equals negative 3. And how are the values in the number sentence related to the distances on the number line? So looking at this, Angel V, what is the distance between 6 and 9 on this number line? How many units is that? Who can help her out?
It's 4.
4 units? Let's count it. Let's look. 1, 2, how many?
3.
3 units. Good. So there are 3 units from 6 to 9. All right. Now, we know that 6 minus 9 equals negative 3. But the question that it asked us is, did you notice that 9 is a distance of 3 units from 6? Well, yeah. We know that 6 and 9 are 3 units apart on the number line. And we also know that the absolute value of the difference is the distance between the values being subtracted. So I want somebody to read number 2 for me on their workbook. Can you read that for me, someone, very quickly, please?
What do the values in the same number in the number sentence tell you about the distances on the number line?
All right. So that I just put in those brackets is our answer. So I want you to do that now, okay? Hello. Hey, buddy. All right, so what were we supposed to have for our answer for number 2? Somebody read that for me real quick, please.
I can't see it. Hold on. The absolute value of the difference is the distance between the values being subtracted.
All right. So for number 2 in your workbook on page 152, we should all have the absolute value of the difference is the distance between the values being subtracted. Can anybody put that in their own words? Couldn't we just say, if you're looking at these 2 numbers, whatever the distance is between them, that's going to be the absolute value of their difference?
But it would be their additive inverse.
All right, so in this case, basically what it's trying to say is that no matter what numbers you're looking at, if you take the absolute value of these numbers, you're always going to be able to figure out what the absolute value of the answer would be. So sometimes, if we have the number negative 3, the absolute value of negative 3, these are absolute value brackets, but the absolute value of negative 3 is 3. Well, the absolute value of 3 is also 3. All right. Now, in order to find our answer, we know that negative 9 is further away from 0 on the number line. But when subtracting 2 numbers, all right, if we were to rewrite this as addition, and we said 6 plus negative 9, we know that negative 9 has a greater absolute value than 6 does, because negative 9 is way over here, and from here to here is 9 units, and from 0 to 6 is 6 units. So that means that our answer is going to be a negative answer. So all you have to do is 9 minus 6, and it equals 3, but we know that our answer is negative because it's a bigger distance from here to here. All right, so our answer would be negative 3 to this question. Okay, so that was just kind of putting it in our own words. So let's take a look at what number 4 says. So this is where it's going to get a little bit different. All right, now, so the reason I say that is because you got to think about Annabelle skating backwards earlier. Okay, So it says, now consider that -3 minus -5 equals 2. How are the values in the number sentence related to the distances on the number line? All right, so take a look at it. What's it trying to show us?
It's trying to show us that -5 and -3 are 2 units apart.
Correct. And so that's pretty quick compared to us taking this problem and changing it to addition, which is because subtracting a negative is the same as adding its additive inverse, which would be plus the opposite of -5, which is
5.
5. And then us taking this and rewriting this as 5 minus 3 equals 2. All right? This is the same as this, but doing it this way is pretty quick. All right? Because we know that 5 has a greater absolute value than -3. And since 5 has a greater absolute value than -3, we know that our answer is going to be a positive answer. All right, so down there it said, did you notice that -5 is the distance of 2 units from -3? Yeah, we just said it was. And so we also know that -3 and -5 are 2 units apart on the number line. So once again, the answer to number 2 states what? Read that for us, Devin.
The absolute value of the difference is the distance between the values being subtracted.
Perfect. All right, so we're going to take a look at number 10. Now, this is in your workbook on that page 152, okay? So I want us to take a few minutes to try to do this. We're going to take right around 2 to 3 minutes to do this. It's 1:23 now. So right around 1:25, 1:26, we're going to check this, okay? So I want everybody to go through and try this, and then we'll work on it together as a class afterwards, okay? And check our work. All right, Devin, you got your hand up, man. Roll with it. Tell us what you got.
So I think the first one is 2.
Okay.
And the reason I say that is because of 5 minus 3 is 2, and 2 plus 3 is 5. You fill it in, and then 3 plus 2 is 5, and 5 minus 2 is 3.
Perfect.
So I think the first one's 2, and then do you want me to do the second one too?
Yeah, go ahead.
I think it's -8.
Okay, explain why.
The reason I think that is because the first one, if you do like the changing thing where you do -3 and then you change it to add like an addition problem, it'd be -3 plus 5 plus -5, and that would equal -8. And then if you did -8 plus 5, it equals -3.
Correct.
5 plus -8 equals -3, and then -8 minus -3 minus -8 equals 5.
All right, so let's show some of that on here. So if we were at -3 and we add -5, like Devin said, we would go back 1, 2, 3, 4, 5 places, and we would be at our answer, which is -8. All right, same thing over here with this one. If we're at 5 and we take away 3, that would be 1, 2, 3, and we would end up at our answer, which is what? 2. Does anybody have anything to add to that or have any questions? If not, give me a thumbs up. All right, we're going to move on along. All right, take a look at this. If you would, let's get somebody we haven't heard from today. Miss Rachel, would you read this for us, please, ma'am?
Archibald and Annabelle have learned some very important lessons about adding and subtracting integers. Archibald wonders how the expressions 10 plus -4 and 10 plus -4 and -4 plus 10 are different.
All right. So looking at this, what is 10 plus negative 4?
6.
It is 6. Everybody should agree with that. 10 minus 4 is 6, or 10 plus negative 4 is 6. Well, what about negative 4 plus 10? If you go to negative 4 on the number line, and then we go 10 units to the right, are we still going to be at 6?
Yes.
Yes.
Yeah, we are. All right. So can anybody explain why? Does it matter what order you add?
Because you're going the same distance from 0.
That makes sense.
Maybe.
Yeah, you're going to end 6 units from 0. All right, on the right side, both times. That does make sense. Yeah, go ahead, Rachel.
I think that it's going to be the same. It's the same answer because it's just the same numbers, but in different orders.
Correct. All right. And that is actually a property that we use in addition. Does anybody happen to know what that property is?
I don't know.
All right. It starts with a C. We'll read about it here. If you would, Akira, will you read this for us, please, ma'am? My Mickey D girl, will you read this? Akira? Akira. She must have muted me. Akira.
Isn't it like a commutative or whatever?
Commutative property.
Yeah, commutative. Now, when I read it, I remembered, but I couldn't remember just thinking.
I got you. It is the commutative property. So the commutative property, remember, is whenever you use any order to add numbers together. No matter what order you put numbers in whenever you're adding, as long as they're the same numbers, you're always going to get the same sum. Okay? So in this case, we took 10 plus negative 4 and we swapped it to negative 4 plus 10. But in both cases, just like Grayson said, we got 6. And the reason is because we were 6 units to the right of 0. Okay? And so, talking about that, if you look at this and you talk about them skating, what did she do skating, Angel? V?
She left 4 units. Well, I don't. She skated right 10 times.
Mm-hmm. And then what? What's it say on there?
Oh, she skated left 4 units.
Yeah. And so it says that gives the same result as skating to the left 4 units and then skating to the right 10 units, just like Grayson said. All right, so let's take a look at the next one. So looking at this, what is 10 minus 4, everybody?
6.
All right. 10 minus 4 is 6. All right, I agree. Now, this is where it's going to get interesting. What is 4 minus 10? No,
Negative 6.
it is negative 6. So we swapped the order of 10 and 4 to 4 and 10. Now, whenever we did that, we got different answers. So can anybody explain why we got different answers?
I can.
All right, go ahead.
We got different answers. 10 is greater than 4, and when you're subtracting, you put the greater number first.
Okay. All right. When working with positive numbers, I guess?
Yeah, when working on positive numbers.
Okay. You don't always have to, because we can get negative answers now. But I see what you were trying to explain there. We know that 10 is larger than 4. So when we take 4 away from 10, we're going to have some left over, right?
Yes.
All right. Well, if we start with 4 and we take 10 away, we're not going to have anything left over. We're actually going to owe. All right. We would be owing for 6. Okay. We would be in debt, just like Devin said. So based off this information, knowing that the order doesn't matter for addition and the order does matter for subtraction, does the commutative property hold for subtraction?
No.
No, it does not. Commutative property is only going to work for addition. Okay? if we change the order of the numbers when we're subtracting, we are not going to get the correct value. All right, the difference is going to be wrong. Okay.
When subtracting, when you get say your original problem was 10 minus 4, and you got 6, wouldn't, like, if you did 4 minus 10, wouldn't it be like its additive inverse every time you would do that?
Yes, it is. It's going to end up being the exact opposite every time. All right. So that's good. Good way to put that. All right. So take a look at this, everybody. We need to complete this puzzle. All right. Now, I believe this puzzle is it on page 153 in our notebook? All right. So we're on page 153.
Yes.
All right. So I need us all to focus on solving this right now. If you need some help, you're more than welcome to raise your hand or use the chat box, or you can ask Mr. Williams or Miss Dooley. So go ahead and knock that out, and we will get started on this. I'm going to give you.
On all of the page or just?
I only want you to work on number 7 right now. And so it will take you probably about 2.5 minutes, okay? So I want you to take that time now and see if you can do it. All right, my boys and girls, let's take a look at this. Let's start with Ms. Khalees. Khalees, why don't you work A for us, A and B? What is 6 minus 11 equal to?
-5.
You're right. It is -5. All right. And so what would B be equal to? Like, what's another number sentence that would be equal to -5 out of those that we were given?
Mr. Moore,
Yes, sir.
I think I messed up.
All right. What happened?
And I'm writing in.
That's all right, man. Just draw a line through it and put the right answer beside it. It'll be okay.
Okay.
If you put them in different orders, that's fine too. It's going to be the same thing. Like if you put -5 on B and you put the answer that we're going to put for B in A, that's okay.
You don't need it.
What's wrong, Khalees?
Huh?
Oh, no, I thought you were saying something to me. What you got, Khalees?
6 plus -11.
6 plus -11 works perfect. All right. So if you had these swapped like this, that's still okay. Does everybody understand that? It doesn't matter what order you had them in. You're still going to get the same answer. All right. Now looking at the next one, we got -5 plus 3 equals something. What is that going to equal, Tamarian?
What's not equal?
-5 plus 3.
In my workbook. -2.
Correct. It is going to be -2. What is another, come on, thing? There you go. What's another thing that we could say, like another number sentence we could use that would also equal -2?
You could use 3 minus 5.
That would work. 3 minus 5 would work perfect. All right, so let's look at E. All right, Natalia, what would you have for 11 minus 6?
+5.
Good. And what's another thing that we could use there to make that work?
6 plus -11.
6 plus -11?
I said 11 plus -6.
All right, so Kalia said 11 plus -6. What are you thinking, Natalia? Because we said that 6 plus -11 will give us -5.
Oh, I got that messed up.
All right, so what should it be?
-6.
Good.
11 plus -6.
All right, lady. All right, so looking at this, we got -3 plus 5. What's that going to be, Kalia?
+2. Well, 2.
Good. And what would we write for H? What else?
5 minus 3.
Perfect. 5 minus 3. Or we could say 5 plus negative 3, right? All right, so pay close attention to what it says down there in the bottom. Will you read that, Grayson?
Great. You can add integers in any order, but you must be careful with subtraction. You cannot change the order of integers in a subtraction problem.
All right, and we said earlier the reason we can't do that is because the commutative property of addition does not work for subtraction. All right, so check this out. We get to actually work with Miss Annabelle and send her either the right way or the wrong way. So we're going to see how well we do. I'm going to try to call on some people that I haven't heard from today. So I'm going to go ahead and call on Mr. Braden. Braden.
Sir?
We got 3 minus negative 7. So what way do you want Miss Annabelle to face, and what do I need to do?
Go right.
Good.
3 times and left 7 times.
All right, so we're at 3. All right, so we checked it, and then he said we're going to go back because it says minus negative 7. So when we see minus negative 7, isn't this supposed to be a key for us? Like anytime we see this right here?
Yes, sir.
What's that supposed to tell us? How are we supposed to rewrite that?
Yeah, adding its opposite.
Correct. So that's really going to be 3 plus 7, right? So instead of our little lady pointing to the right, we need to turn her around and have her back up 7 spaces, okay? So we're going to turn her around just like that, and she is going to moonwalk like Michael Jackson all the way back to what number? Oh, she didn't moonwalk. I thought she was going to moonwalk. All right, she's backing up all the way to what?
10.
All right. Does that look good? Now all we got to do is put our answer in. So we got 10. Anybody have a question about that? This is the time to ask. Braden, does that make sense?
Yes, sir.
All right. Let's look at the next one. Brendan, I want you to do this one. What would I do, Brendan?
Move forward 5.
All right. Since it says negative 8 first, I need to do this one first. Because we work from left to right. So how would I do that?
Oh, move backwards 8.
All right, so let's do that. We're going to move her back. She's pointing in the right direction, right? Yeah. Yeah, she's pointing in the right direction. All right. Oh, no. Is she facing the right way?
No, she should
No.
be left.
Yeah, she's got to face the left. I was trying to see if anybody was going to catch it, but nobody caught it. All right, so why does she have to face the left?
Because we're moving left.
Correct. All right, so we're moving to the left. All right, so we're at negative 8. Now it says it's going to add 5. So if we're adding 5, does she need to face the left or does she need to face the right?
The right.
Okay. And now we're going how many spaces in which direction?
5 to the right.
All right. And so what did we get?
Negative 3.
Good. Does anybody have a question about why the answer is negative 3? Everybody feels pretty confident? Make sure you give me a thumbs up if you feel confident. If you don't, throw me a thumbs down. Don't be afraid to let me know. All right. Angel, you got a question?
No, I just wanted to say that I'm confident.
All right. Good deal. I got you. Doing
In my
good.
own way.
Proud of y'all. All right. So let's move to number 3. All right, this is the last one that we got like this. Let's see if Miss Asia can help us. Asia, which way do I need to be facing, and what do I need to do so that I can knock out the beginning of this problem?
Wouldn't you go to 4 to the right?
Good. That's what we'll do. We'll go 4 to the right. All right. Now, what would we do to subtract 8?
Would you go to the left to 8?
All right. Do I need to face the left or face the right?
Face the left.
Okay. And then we're going to go back 8 places. All right. Uh-oh. What's it say? Which way did we needed to face her?
Right.
To the right, because we wanted her to skate what? Which way did we want her facing? I mean, which way did we wanted her facing to the left so that she could skate what?
Backwards.
Backwards. Now, does it really matter which way that ant faces? No. Did Asia still get the right answer?
Yeah.
Yeah, she got the right answer. The only time that this really matters, which way that ant's facing, is whenever they're trying to show subtracting a negative number. That's the only time it really matters. So, Asia, you did a great job. You got -4. They just tried to trick us on which way that ant should face. All right, so we got -4. Come on. Oh, I got to turn her around. There you go. Anybody have a question about that problem? Look at the ant's face. I didn't notice their eyes. They got those fake eyelashes. Y'all see it? Nobody.
Yeah.
Nobody
Kinda
laughed.
weird.
Nobody laughed. Just me. It's okay.
No, I laughed. My mic was just off.
I'm just tricking. Yeah, there it is. All right, here we go. So take a look at this last problem we got right here. Miss Satari, will you read this for us, please, ma'am?
The part where it says on the time zone?
Yeah, talk about Archibald's parents first, though.
Okay, all of it?
Yes, ma'am, please.
Okay. Archibald's parents want him to call them at 6 p.m. in New York every night while he is in Hawaii. Can you solve the parts of this puzzle? On the time zone line, New York is represented by the integer. Hawaii is represented by the integer blank. Using the integers for the times, find the difference. Hawaii minus New York. Now find the time in Hawaii when it is 6 p.m. in New York. 6 plus blank. Therefore, to make a call when it is 6 p.m. in New York City, you should call at blank time in Hawaii.
All right. Y'all take a minute and see if y'all can do this on your own. I got faith in you. Let's take a look at it. On the time zone line, New York is represented by what integer? Sophia.
-5.
Oh my goodness, she popped it out there quick. All right, good job. Sophia, I want you to do part B. Hawaii is represented by what integer? Come on, Sophia, you can do it.
I don't know. I blanked out.
What? Look at this. Look on here. Look for the integer that is represented by Hawaii. So find Hawaii, and then we're going to go up and see what integer it is. What integer is that?
-10.
Yeah, -10. All right, Grayson. It says using the integers for the times, find the difference, Hawaii minus New York. So we have to do Hawaii minus New York.
Would it be -5? Or no. -10 minus -5. Or no, +5, right?
Well, yes, that's what it will be. -10 minus -5 would equal what? Correct.
Okay.
Okay. And now it says, now find the time in Hawaii when it is 6 p.m. in New York. So if it's 6 p.m. here and we're going back, let's put a 6 there. We're going back 1, 2, 3, 4, 5 hours. Is this earlier, 5 hours earlier, or 5 hours later?
Later.
Right.
It would be earlier.
Yes,
Earlier,
it's going to
yeah.
be
No,
earlier.
you're right. Yeah.
Earlier, because we said if it's on the left of the UTC, it's early. If it's on the right of the UTC, it is later. Okay,
I was just thinking about the negative.
that's all good. So we're at 6. So what is 5 hours earlier than 6?
1.
Okay, it's 1.
1.
So 6 plus what is 1?
-5.
Correct.
5.
So therefore, to make a call when it's 6 p.m. in 6 p.m. in New York City, you should call at what time in Hawaii?
1 p.m.
Isn't that crazy? Isn't that kind of neat? How it's that big of a difference across the world? I think it's cool. All right.
Yeah, me too.
So that was page 14. We're going to look at page 15, which is our last page on here. So it says, in this exploring, you solved integer addition and subtraction problems. Now you can relate addition and subtraction number sentences to real world context. We're going to drag the tiles to complete the table. All right, so look at the first one. It says, Brian starts a hike in a deep canyon at an elevation of negative 50 feet. Okay, so he's 50 feet below. And then he hikes to an elevation of 20 feet above zero. So what is that distance? If you're 50 feet below zero and then you hiked 20 feet above zero, how far is that, Devin?
-30.
Ooh, I don't know. Do y'all think so?
Wait. No, would it be -70?
Well, if you're at negative 50,
Yeah.
all right, so you're all the way down here. This is zero. And then you go all the way up here to 20. And I'm counting the space from here to here.
7.
It would be positive 70. You're right. So which one of these is going to equal 70?
The first one.
It is. It's going to be the first one. So we got to take that. We're going to put it right here. Or we're going to try to. All right. Now the next one says Carla owed her sister $50. If you owe somebody $50, how would you write that?
-50.
Okay. All right. Both of those have a negative 50. Now it says she paid her $20 back. So if you paid somebody, would that be a plus or minus?
A plus.
All right. And so it says, how much does she owe? Well, if you owed 50, then you paid 20, how much do you owe now?
$30.
That's right. You owe 30. So looking at those answers, which one's it going to be?
The middle
Second.
Yeah, it's the second one. Good job. All right. So that automatically knows. I mean, that means we know what the last answer is going to be. What do I need to do with this third one?
I mean, you could solve it.
Yeah, we're going to solve it, but I just want you, test-wise, if you ever find the first two automatically, well, then you know the third one has to go there, right? So you don't even have to waste that time. But since we're in class, we're going to go over it. Okay, so it says a small town in Russia experienced a high temperature for the day of negative 20 degrees. That night, the temperature fell to negative 50. So how many degrees did the temperature actually fall? Grayson raised his hand. All right. What do you think, Grayson?
If it started at 20 and then ended at 50, it fell 30 degrees.
Correct. It fell 30 degrees. That is right. Because you're at negative 20, which is like right here. And this is negative 50. And so from here to here, that is 30 degrees. Why is it a positive 30 degrees? Because absolute value is always what?
absolute
The
value
opposite.
is always the opposite.
No.
Or it's distant
Yeah.
from 0.
Distance is always from 0, and that means that distance will always be what? Starts with a P.
Positive.
Positive. Great job, Grayson. All right, guys, my boys and girls, this is what we have to do to finish today. You have questions on number 10 and number 11 in your workbook. This goes for my class and Miss Chumley's class. You need to work all the questions, 10, A through I, and 11, A through F. Do those tonight. We'll review any that you need to, okay? And I will see y'all on the next time. Y'all all have a great day, okay?